Let's look at some chain rule derivatives. So here we have our outer function is this fourth root. And we have our inner function right here, which is the 1 plus 2x and then plus the x to the third. So I would like to rewrite y. I'll write that as y equals 1 plus 2x plus x to the third, and I'll do that to the 1/4 power. It's a preference, but I prefer to have the exponent for the power as opposed to working with the square root. So that means for our derivative, we bring down our power, rewrite our parenthesis, and now when we subtract 1, 1/4 minus 1 is -3/4. And then rewrite what we had, 1 plus 2x plus x to the third. Then we need to do our chain rule. Our chain rule says we take the derivative of what's inside our parenthesis. And in this case, the derivative of 1 goes to 0, the derivative of 2x is 2, and the derivative of x to the third is 3x squared. So it would look like this. This is another one where simplifying isn't really going to help us out too much, so I'm going to leave it there. The next one's extra tricky because we have a product rule and we have a function within a function right here with our e to the negative x squared. So we need to use our product rule and our chain rule. It needs to be a little combination for this one. So let's see if we can figure it out. If we go to take the derivative, so we need y prime. The derivative says you take the first, so in this case our first term is x, times the derivative of the second. Well, here's where it gets tricky. That's where we have our chain rule. So the derivative of e to the x is always e to the x. And then we need to do the chain rule on our negative x squared. So that's going to give us -2x. So all of this is just the first times the derivative of the second for the first part of our product rule. To finish our product rule, we need our second times the derivative of the first. Well, the derivative of x is just 1. It's not really going to help us out too much to try to clean this up. We can factor out and we can do a little simplifying. So if we simplify it a little bit, we can do x times -2x. That'll give us -2x squared. And we have an e to the negative x squared plus e to the negative x squared. You could factor out the e to the negative x squared. And that would leave -2x squared plus 1. It's okay to leave these in any of these forms. Sometimes factoring doesn't help, and sometimes it helps a little bit. Let's try another one with our product rule within our chain rule. So looking at part C, here is our product rule, here's our first, and here's our second. But in both cases now, our second is a chain rule in and of itself. So we have to be very careful as we work this through. It's going to be long, so I'm going to start all the way over here on the side. So our derivative says to take our first, so rewrite the first. So 1 plus 4x to the fifth times the derivative of the second. Well, the derivative of the second means we bring down our power, so there's the 8, and then subtract 1, so that makes it to the 7th. And then rewrite what's inside, 3 minus x squared. But that is a function in and of itself. So that means we need to do the chain rule on this piece. So our chain rule is going to look like the derivative of 3 is 0, the derivative of -x is -1, and the derivative of -x squared is -2x. So let's make sure that we didn't miss anything here. We have our first, we have the derivative of the second with our chain rule. Now that's only the first half of the product rule. The product rule then says plus the second. I'm going to go to a second line or it's going to take over all the space. So plus the second. So rewrite the second. That becomes 3 minus x squared raised to the 8th power times the derivative of the first. Well, the derivative of 1 plus 4x raised to the 5th would be 5. Bring down your power. Rewrite, subtract 1. And then inside we have our 1 plus 4x. I can move this over to save a little space. And then we have a chain rule again. Right here we have a function within. So we have to do our chain rule. The derivative of 1 is 0. The derivative of 4x is 4. So this one got very long. I would not try to multiply it out. I don't want to expand something to the 5th, to the 7th, to the 8th, and to the 4th. So I would just leave it right there. Part D is very similar. We have a product rule and the chain rule. So let's give this a try. Start with your product rule. Product rule says the first, so t to the 4th minus 1 to the 3rd, times the derivative of the second. Well, the derivative of t to the 3rd plus 1 quantity to the 4th is going to look like 4 times t to the 3rd plus 1 to the 3rd. And then we need to do our chain rule. So that will look like 3t squared. Now that's just the first half. We have the first t to the 4th minus 1 all to the 3rd times the derivative of the second. So that's where we have our derivative with our chain rule. Now we need plus our second. I'm going to start a second line again just because it's so long. Times the derivative of the first. Well, the first is t to the 4th minus 1 to the 3rd. So bring down the power, rewrite to the second, rewrite what was inside the parenthesis, and we need to use our chain rule on the piece inside the parenthesis. The derivative of t to the 4th is 4t to the 3rd, and then the derivative of minus 1 would go to 0. So these are a few examples of using the chain rule and the product rule combined.